Everybody should have a flag. They may not actually look like a flag. They're a construction paper with a binder clip on the bottom. These are the flags. You each get a flag. What I want you to do is take a minute to read this problem and then decide, are you going to put your flag on green, which means you're good to go, you're fine with solving this problem on your own, or yellow, you're going to work through this problem with me. If you start on the problem on green and then you realize you need to flip over to yellow, that's fine. If you start on yellow and you reach a point and you're like, I'm good, coach, I'm going to go to green, that's fine. But take 1 minute, make a decision. I want you guys to get lots of practice time today. And this will be the quiet part of the time. Sorry about that. I didn't. Right now, your flag is on green or yellow. There are no black mollies.
Isn't it the fish?
We're not talking about the fish. That was so yesterday.
You can tap
I don't see Ron Beer and I don't see. Alright, so I've seen a lot of people that have successfully separated the variables. They multiplied both sides by dx, dy equals x e to the negative y squared dx. Then they're dividing both sides by e to the negative y squared, and they make it to dy over e to the negative y squared equals x dx. How many of you guys honestly made it there? Okay, getting there gets you the first point. If you've made it there, keep going. I'm open to any and all the questions. No, Amy.
What do you do with the y?
What do you do with the y? What do you mean?
On top.
Ah, the y on the top. How about like I write it? Yeah. Yeah. Yeah, we're good. That's the thing. Thank you all for being there for me. Okay, we're good. Now we come to Anthony's favorite part. Integrate both sides. One side is almost always easier than the other one. I hope you guys all see the easy side here. Right, what's the integral of x dx?
1/2 x.
1/2 x squared plus c. You successfully integrated the guy on the right and you remember the constant of integration. Congratulations, you're up to 3 points. Now the trick is, how on earth are we going to integrate the guy on the left? For those of you that know what you're doing, your flag is on green. Keep going, I don't want to talk to you. I just want to talk to folks that have a flag on yellow because they're seeing this and they're like, whoa, slow the roll. Thoughts from the folks that are on yellow? What are you seeing here? David, what do you see?
Yeah, it's basically 1 over e to the negative y squared.
Okay, so we've got 1 over e to the negative y squared times y dy. How does that help you?
It helps because then you can just flip it around, so then it would into e to the negative, to the y squared.
E to the y squared times y dy. For right now, I'm just kind of leaving this side over because I'm already done over there. All the work happens over here. We need some cleverness. How are you going to integrate e to the y squared times y dy? Edgar's got some thoughts. This looks like a really ugly integral to me. That's a hint. That is the biggest hint I could give you. The uglier the integral, the more likely it is. Anthony, what are you going to do? Substitution. If you're seeing substitution, my question for you is, what's the baby?
Y squared.
Y squared. What's that derivative?
1.
Oh gosh.
No.
The derivative is going to be 2y. Right? And then you multiply both sides by dy. So u is equal to y squared. Du equals 2y dy. I don't have 2y dy, I just have y dy. You guys know what we're going to do. Right, multiply everything by a half. So now you get a half of du equals y dy. So now let's do the substitution. I'm not going to talk about e to the y squared anymore. I'm going to call it e to the u. Instead of y dy, that's this 1/2 du. We are moments away from having successfully integrated the guy on the left. Folks that are on yellow, what are the thoughts here? What could you do? Eunice, what do you see?
Could you move the 1/2 to the other side?
Okay, why can I take that 1/2 out?
Because it's constant.
Okay, it's a constant, so the 1/2's out of there. Now I just have to answer the question, what's the integral of e to the u du?
E
to u plus
The integral of e to the u with respect to u is
u plus
e to the u. Right, so like 1/2 e to the u plus c if you want to. Then we're going to go back and do our substitution and say 1/2 e to the y squared plus c. All the stuff that just happened over here was substitution. Okay. So now we've got a half of e to the y squared plus c equals a half x squared plus c, and you definitely picked up a point here, possibly even 2 points. Good news, the calculus is done. You separated the variables, you integrated both sides. The only thing left is a whole lot of algebra. I just need some clever algebra thoughts. Edgar's got some clever algebra thoughts, David's got some. Adriana's got some. Jonathan, what you got for me?
subtract c, and then multiply it.
Wait, what do you want to do?
Subtract c.
Okay, so you subtract, right, really I've got like C1 and C2 here. So I've got a half of e to the y squared equals a half of x squared, C2 minus C1, you know something about that, right? Super Charlie! So you can just call it Super Charlie. I heard you say multiply by 2. Great, let's multiply by 2. E to the y squared. 2 times a half x squared is x squared. 2 times c. Just going to call it c. Not done. Not done. Edgar, why are we not done?
Because we still have e there and y is the next one. So
How am I going to get rid of the e?
natural log.
Right, we're going to take the natural log on both sides. We're not multiplying by the natural log. You're going to say, oh, natural log of e to the y squared equals natural log of x squared plus c. These guys are inverses, they cancel. Y squared is the natural log of x squared plus c. Going to take a square root on both sides. Plus or minus. Getting there, another point comes your way. Not done. You guys all know we're not done. Why not? Why are we not done? David, what you got?
You said you plug in the initial condition.
Yeah, what is the initial condition?
Y intersection.
Right, this guy here, it's phrased differently than the way you've seen it before, but this is your initial condition, and you're about to make your Algebra 1 teacher really, really proud. If the y-intercept is -2, think back to a graph. The y-intercept is -2. What's the thing that you know? You know, Nora? You know that x equals 0 and y equals -2. So that's another way that they're like hiding that initial condition on you. From here, just plug it in. It should be nice and easy. -2 is plus or minus the square root natural log 0 squared plus c. Are you okay? -2 equals plus or minus the square root of the natural log of c. Let me square both sides. Square root of natural log of c, square that. Natural log of c. To get c by itself, exponentiate both sides, so c is equal to e to the 4th. It's not a pretty initial condition or a constant, but that's all right. So then you'll say, all right, so y is going to be plus or minus square root natural log of x squared plus e to the 4th. I like it. I don't love it. I want to love it. I hope to love this. Edgar sees it, Anthony sees it, maybe Adriana sees it. Giselle, what's the issue here?
We need to decide whether we're gonna have it be positive or negative.
Right, when it comes to working with these square roots, our answer to a differential equation has to be a function. Having this plus or minus, it is a choice I need to make. Do I take the positive or do I take the negative, Edgar? Which one? Edgar, Abraham. I've got 77 days till the AP exam to figure it out. Do I take the positive or the negative? Why?
Because it's the y.
Right, you look at the y value for the initial condition to decide which way you're gonna go. So, there it is. And at that point, mission accomplished. That is probably one of the ugliest separable differential equation problems I'll ask you guys to do. All right, try the next one. Take a minute or two with somebody close by. If anybody has any questions about all the beautiful math that just happened, Juan, now's the time.
Where did the so in the last column, the e to the fourth and e to the, is that e to the natural log of 3?
So I've got negative, were you okay with negative 2 equals plus or minus square root of natural log of c? To figure out what c is, you square both sides.
Oh, and then, yeah, okay.
So now I've got, the top part was 4 equals the natural log of c. You want to get c by itself, so you exponentiate both sides. That's how the e and the ln cancel out.
Separated. But it's still. They can't be separated.
Now, why did you write it? Why did you write that? Perfect. Right, as soon as you see that word slope in calculus class, we're talking about the so dy dx equals 3y. Good, keep going. Right, right. If it's going to be a differential equation, you need to get a derivative in here somehow.
But it overheated.
How do you know that? Because we're talking about the slope. The slope at any point is this 3y over x. So we'd say 3y over x equals dy dx. So this is your differential, which is dy dx.
That's range stuff.
I just think that I
So
just put it
now
down
you
to
gotta
3.
decide how much
Can you take
if
you
it's a
add to
separable differential equation, means you can get all the y's and the dy on one side, and all the x's and the dx on the other. If I'm going to do that, then you integrate both sides.
Yeah,
But then.
I think you're right. Yeah, you're right.
dy is on.
No, I think you're right.
Oh, yeah.
I don't think I
I
have
think just about everybody's at least got the initial differential equation set up. Right, dy dx equals 3y over x. Jennifer or Ortiz. Ortega! Sorry, I was thinking about a different Jennifer in my life. dy dx equals 3y over x. Why? What did you read that said to set it up that way? Right? It says that in this one, determine the equation of the curve, pass it through that point, and the slope. In calculus class, that's always dy dx. What I hope is that for most of you guys, once you get here, your algebra skills kick in. Right? I want to get all the y's and the dy on one side. What can we do here? probably still gonna multiply by dx. So dy equals 3y over x dx. I need to get the y down here so I can divide. So I've got 1 over x dx. How many of you guys are able to successfully get here? Okay, the other option is you could have left the 3 over here. Okay? So you could just say, let me divide both sides by y, but not the 3. Either way, great, integrate both sides. dy over y, we know that's really the same as 1 over y dy. Over here, 3 over x dx, integral of 1 over y dy, natural log of the absolute value of y. Integral 3 over x, 3 times the natural log of the absolute value of x plus c. 1 point for separating the variables, 1 point for integrating on the right, 1 point for integrating on the left, 1 point for the constant of integration. Life is good. Yeah.
If you had kept the 3 with the y, it would be 1/3 natural log.
Right, if you brought the 3 over here, then you could factor that 3 out in the front and you'd have 1/3. Okay, if I want to get y by itself, you guys know how the story ends. You want to get y by itself. You're going to exponentiate. Because here, those guys cancel out. Absolute value of y equals e to the 3 natural log of x plus c. Here's going to be the place where some weird stuff happens. E to the 3 natural log of x plus c. I'm going to choose to write this as e to the 3 natural log of the absolute value of x times e to the c. Legal?
Yeah.
Legal, right? The bases are the same and I'm multiplying, and that's when I would add exponents. The reason I would do that, though,
Make it even bigger c.
right? It's this guy over here. E to the c is just super Charlie again. So now you've got absolute value of y equals e to the 3 natural log of the absolute value of x times c. You haven't solved for y yet. We've got to get rid of those absolute value bars. And we talked about this part yesterday. The way you get rid of the absolute value bars. If the absolute value of y equals all this stuff over here, then what is it that we know
Plus
about
or
y?
minus.
It's plus or minus. That's how you get rid of those absolute value bars, because absolute value bars just make negative things positive. So we're going to have plus or minus e to the 3 natural log of the absolute value of x. Not going to trick you guys here. Plus or minus c, that's another super Charlie. So we get y is equal to e to the 3 of y equals c. E to the 3 natural log of the absolute value of x. We're like a moment away from being done.
0.11.
Right, if you've got an initial condition, go use it. We know that when x equals 1, y is equal to 1, so 1 equals c e to the 3 natural log of 1. Natural log of 1, you guys know, is 0. Times 3 is still 0. And e to the 0? 1. So c is equal to 1. So final answer, if all goes well, is y equals e to the 3 natural log of the absolute value of x. And this answer is 100% perfect. Cannot get any better. However, I show my love by pushing you. That is a great answer for the free response, and it may not show up on the multiple choice. I want you to put a little star next to this one in your notes, and you guys are going to get some practice time. There is some legal stuff that can happen here. It's probably not what you would naturally choose to do, but the AP folks are going to hide this answer from you in the following way. Here's what they're going to say. They're going to say, well, you know, if they're in calculus, then they know that when you have a number in front of a log, there's a legal thing that you can do here. You can bring that up as the exponent. Now, why would I do that? Because now I've got y equals e to the natural log of the absolute value of x, the whole thing cubed. Right? It's that p in front of the log property that you guys learned in Algebra 2. But the reverse of it, why would anybody ever do that? Why would anyone ever choose to do this? There has to be a reason. Marvin, what do you see?
Each of natural log of x, just leave it as that.
The E and the ln are inverses of each other. They're going to cancel out. Meaning that the best final answer is going to be that y equals the absolute value of x, the whole thing cubed. Here's what I hope. I hope everybody was 100% here, separating the variables and integrating both sides. Is that pretty safe and pretty comfortable for most folks? Right, after that, now you start solving, you use the initial condition. Jonathan, if you turn that off, that would be great. I would hope everybody can get here. Free response, that's all the points. But they could hide it from you with some exponential trickery. All right, so with that, I want to stop talking. I want you guys to get an opportunity to get rocking on the problem set. Skip past the panda bear. The problem set that you guys are going to turn in on Monday is the 5 multiple choice questions plus the open-ended problems on the back. For the next 15 minutes, I want you guys to spend some time on the multiple choice problems. This is going to be great preparation for Monday's quiz on differential equations. 15 minutes from now, we'll pull it together, look at an application problem, and we'll look at panda bears. And whoever's got the longest hair, you are in control of the cups. And we're talking about hair on the head, not hair on the legs. Not interested in leg hair. 15 minutes, make it count.
So where are these?
Limits for the hardest thing ever. Calc BC, they're coming up on the problems where one problem is I'm going to break the CO at some point.
Just X, 110 X. Just find the answer.
You want the 10 there?
10.
I just took the 10 and the 1. Added in.
Isn't it 110?
I just divided the y and then that just makes it. It just makes it.
Isn't it 110 X?
1 plus x.
You find the answer derivative.
No, because x derivative was negative 10.
Negative 10. It's just negative 10 X.
Totally your choice. As long as you are legal math to separate the variables. Constants can be on unknown. So for example, if one says, hey, I'm going to multiply both sides by 2, you're going to get y equals negative 10, y dx.
I was trying to bring it up.
Again, so
Okay, this is what I had. I had negative dx equals negative 10y. Because like I multiplied dy on both sides and got 1 over dx.
So legally, how can I get rid of this y without breaking algebra?
And then I multiplied everything by
I'm going to
negative
divide both sides by
to get
1.
rid of the negative dx.
So do y over y equals negative 2. But if Martier says, you know what, like, I think that negative 10 is connected to the y and I want to divide both sides by negative 10y, that's okay. But you would have dy divided by negative 10y equals.
So they don't just like this.
That's what
Oh. I think I like this. Yeah. Whenever I hear somebody say, can I go to the bathroom, what I really hear is, I'm
Can
so
I waste
bored.
time?
Yes.
Can I just waste your time?
So you're dividing.
If you have to go now,
It's not plus C.
please make sure you grab the pass.
Whenever you do the, you try to take out the notes from on the right, and you did the E, you, yeah, it's not plus.
Jonathan,
X.
Giselle. Giselle. Here we go. Mariah. Noemi.
Yeah.
Jose.
Or 10
Yeah. That's how
I
I
would
was
want
like,
to take
you
that
number
negative
one.
10 and
Because
really
I was
see it
like,
as
what?
that's a negative 10 in the denominator, so it's like 1 over 1. Times 1 over 1. And so you can pull that negative 10 out from the integral as 1 over 1.
No.
Christian, Abraham, Edgar, David, you okay? Don't punch your eyes out. Martyr. Laura, this got dropped off for you yesterday. Mariah, you doing okay over there? Everything come out okay? All right, good. Let me. Thank you very much. Thank you very much. Yeah, I think I'm an older man. Is that right? Is, so dy over y is the same as dy times 1 over y. 100%. And hopefully that makes the integration easier.
Makes sense. Like to have negative 10 to 1 negative.
Once you integrate the dy or the dx or the dt, they're there in the beginning to tell you this is the variable I'm integrating for coefficient. So whenever you're writing an integral sign, there's always going to be this sign. But once you finish integrating, you no longer need the y or d's. Okay, friends over here, how are we doing? Let's see so far. Where I worry about you the most is the notation. Okay, you're like Caroline when she said, "No, Dad, don't come check my room." Oh, okay, don't. Okay, I should look up here. So I'm gonna look and I'm gonna say, okay, Jose understands to separate the variables, dy, the dx, great. I'm gonna say, wow, Jose even understands how to integrate all the things and gets the concept of integration. Fabulous. But I will tell you, when you start doing the weird things that you do, like forgetting to write the integral sign, I'm saying, there have been moments in your life, oh, here's one right here, where we didn't actually bother to write the integral sign on both sides. See, that's the problem. You start thinking you're implying things that you actually are not.
Why is the power of 0 1 to be 0?
So without the integral signs, you may not get this
Like
right.
when you didn't take a derivative.
It is, I understand that dy times 1 over y is rather log of the absolute value of y. I understand that this negative 10 became negative 10x plus c because you integrated. But unless you actually have the notation there to tell me what's really going on, I might not. Especially if you think about you're heading off to college next year and they're not going to know you at all. Oh, I have no doubt. they'll figure you out very quickly. And they're gonna say, "Where did you come from?" And I'm gonna say, "Me." Okay, we've got about 5 more minutes before we move into an application problem. The answer to number 1, if you think you've got it, just look up. If you're looking for a challenge, try number 4.
Yeah, okay.
Alright, Giselle, I'm pretty convinced I can erase all the stuff that's on the board.
It's 1 over x, right? Yeah, I think 1 over x is 10.
Is it C?
Yes, sir.
That's C.
Is number 4.
You mean number 3? Oh, yeah.
Do exponential.
Exponentiate? Exponentiate? No. But considering the number of times I call you Abraham and I think it's the same thing, I think we're even. Expo poet?
The rate of change would be isn't it 1 over T? It's 1 over T. It doesn't matter. That's what I'm asking.
No, I'm right. You're supposed to get ET.
Wait, what is it? Yeah, is it, yeah,
Oh, baby, not on now. Yes, it's
is it B?
Oh. So then what is, oh, C is 50?
I mean, we're learning about K. I thought it was 1 over T. I thought it was K over T.
I don't know how to use that cosine. What is cosine? Nobody knows. Maybe. There's nothing.
Because that's
It's talking about pain?
no, like K is like the
We could, maybe it's C.
he caught us on
The
like
bottom, you have to take it up. So change right to negative.
whenever we did it, there's like K over T.
Right. Because K is a constant of proportionality. When you say things are directly, I know this is inversely proportional, but when you say that they're directly proportional, it just means one goes up and the other goes down. But it's possible that this guy over here is 5 times what this guy is, or it could be 10 times what this guy over here is. All we know with directly proportional is that the first variable is some constant times the second. But you don't know yet what the constant is. With inversely proportional, the first variable is a constant times the reciprocal percent. Yes.
What I got. Yeah, DB and Uncle was like basically 1.
No,
Yeah, Papa was like,
Sorry.
Stop distracting the boys.
I know, right here, like this. Got that right. Yeah. And then,
You still put T, right? Okay, not that constant. You don't even know.
All right, calculus friends. I want to make sure that we're all clear on what this problem set is and what you should get done tonight. Walking around, there are lots of groups that got 3 or more of the problems done. Fabulous. The problem set is due Monday. The smart thing to do tonight is get all 5 multiple choice problems done and 1 or 2 of the problems from the back. That is going to put you in a good place so that you are not overloaded on the homework this weekend. The whole thing is due Monday at the beginning of class. I understand on Monday we have a pep rally schedule, so class is a little bit shorter. Monday you guys have a quiz on differential equations, which should be a very good, very comfortable experience. I'm not picking any of this up tomorrow, but definitely make sure you get all the multiple choice done so that if you have any problems, we can talk about multiple choice tomorrow. Don't worry, March, we're sitting at 15 minutes. Okay, so here's what I want to do. I want to hit our first application problem. So if you guys find in the handout, I think it's on page 2, the panda bear. Finally, we're back to the panda bear. This is our first application problem involving differential equations. The biggest challenge is going to be if you read through this application problem, the introduction, there is not a single differential equation given to you. You're going to have to pull out the important information from this. So I want you to take a minute on your own, read through this, identify all the good information, all the things you would normally do when faced with a problem like this, and then we'll talk. We'll go from there. Important information that you pulled out of the problem. I'll take anything from anyone. C1, C2, C3, C4. Juan, what you got for me?
The rate of change of panda bears population in the second time is directly proportional.
The rate of change of the panda bear population is directly proportional to the number of panda bears at that time. The key phrase here, directly proportional. As soon as I see directly proportional, this is something we talked about the other day. Right, directly proportional. One of the things you guys would have talked about back in like 8th grade math is that it means y equals k times x. One variable is a constant times the other one. Other things. Other important things that we pulled out of this. Adriana.
T is measured in years since 2007.
Okay, so T is going to be years since 2007. Other things. Nora.
So at T equals 0, PT equals 2000.
At T equals 0, the population is 2,000. Right, because T is years since 2007. At time 0, 2,000 panda bears. Not teddy bears. There were more than 2,000 teddy bears in the world in 2007. Other things? Nobody else found anything else important. Edgar, what you got?
T equals 7, the population is 3,000.
At T equals 7, the population is 3,000. Okay? Nora.
At T equals 13, the population. Oh, that's what you're solving for.
Right, at T equals 13, that's actually what I want to know. What's the population going to be at T equals 13? You don't know. That's what we're going to have to figure out. Here's the tough question. The hardest part is going to be, how do you start? What actually is the differential equation that you would write based on this statement? The rate of change of the panda bear population with respect to time is directly proportional. I want you to have a conversation with somebody near you. What would you do?
We plug in 2004.
What's the differential equation?
Like dt over dt.
If that's what we studied at teachers, it's okay with it. And then we just find the rate of change, each node between these two, and that would be x. And that would be, no, I mean, that would go.
I've not seen the right differential equation yet. A lot of folks are getting close. I need a derivative equation.
Keep on the slope.
I thought that was number 7.
Still haven't seen the right differential equation. No. No. Okay. All right, so here's the good news. Here's the good news. Rarely does the College Board do something like this to folks on the AP exam. And I think it is because there's a lot of reading that you have to do before you can even get to the math. I just walked around. Nobody in the room has the right differential equation. So let's have some conversation about this. Everybody's okay with the directly proportional. What are the things that are directly proportional? The rate of change of the panda bear population. We're in calculus class. Rate of change means derivative. Derivative of what?
dt.
Derivative of what? The rate of change of what? Of the panda bear population with respect to time. I want to measure how that panda bear population changes over time. The way I'm going to write that is dp dt. This is rate of change, because it's a derivative, of the panda bear population over time. Okay, let's keep going. That is equal to a constant times, well, what are we directly proportional to? Not time. We're not reading carefully enough. What comes after directly proportional?
Number.
The number of panda bears. How do I represent the number of panda bears? P. Not time, not some linear equation. This is rate of change of the panda bear population equals a constant times the panda bear population. I bet now that you guys are here, life gets good really quickly. What's the strategy? What are you gonna do? Oh gosh. Jose, what are we gonna do? Separate the variables. Tell me how you're gonna legally separate the variables here. Yeah, Jose, how are you gonna legally separate the variables here?
Multiply by dt.
Multiply by dt. So dp equals k times p dt. Have we separated the variables?
No.
No, why not?
We still need to divide it.
You gotta get the p over on the dp side. So I'm gonna divide both sides by p. dp over p equals k dt. Have we separated the variables?
Yes.
dp and p on one side. dt, now there's no t over here, this is a constant, but that's okay. I've separated the variables. Next move, Jasmine, what are we gonna do?
Find the definite integral.
Not a definite integral.
Indefinite.
An indefinite integral, basically just integrate both sides. So I've got the integral of dp over p. I bet everybody knows the answer there.
Natural log of
Not natural log of p. I really want to give you the answer. Natural log absolute value of p, integral on the right. K is a constant. K is a constant. Like 4.
KT.
T.
It's just k t plus c. 1 point for separating the variables, 1 point for the integral, but only if you get the absolute value bars in there. 1 point for integrating on the right, 1 point for the constant of integration. I'm going to go right down the line. That's where the points come from. Mariah, what's your next move? You separated the variables. You integrated both sides. Next move. You can plug the numbers in, like use that initial condition, or
Solve for P.
right. Normally we say solve for y, but really it's solve for the dependent variable. What are we going to solve for here? P. Solve for P.
X for the,
Still know what that word, huh? Natural log of the absolute value of P equals KT plus C. Exponentiate. Because here they cancel. Absolute value of P equals e to the KT plus C. Eventually we're going to get to the plus or minus, but I'm going to make a stop first.
oh,
Not you. You all the time. You all the time too. I'm just going to start. I think we need to go to popsicle sticks. Jennifer, saving us from popsicle sticks.
You have to, you can separate it from like e to the k t times e to the c.
Okay, and that's legal?
Yeah.
And better? Alright, better because e to the c, that's just one of those fancy constants. So, absolute value of p equals c e to the kt. Mariah, what did you say you wanted to do next?
Plus or minus. Take off the absolute value.
Take off these absolute value bars. P is equal to plus or minus c e to the kt. But hey, guess what? Super Charlie again. So P equals C e to the kt. I was hoping that some bells might be going off in your head right now, that looks familiar. That form looks familiar. I always hope the bells and whistles go off in the AP Calculus student brains, but they rarely do at this point. This form ought to look familiar. You know what I mean?
Is it 1 over kt times, is it like the antiderivative?
No, I'm hoping that this equation or this formula looks familiar. Like something you've played with before back in Algebra 2 and in pre-calc. Anthony, what are you thinking about? Oh, you have a question. Ah, okay, what's your question? An equation?
regression.
Regression. I want to hold on to regression. Marvin, what are your thoughts? It's like ax squared, like not at all. Yeah, like not at all. Jennifer?
No, that's
We used to use that, they used to thought it was like part and like K is the rate.
Everyone's like, per? What? Like when you talk about like exponential growth rates and you talk about like banking problems and compounding problems, and there was this formula that you guys had called
Per, p e to the r.
PERT, and the P stood for, the P stood for, who knows? Okay, R stood for rate, T stood for time, A stood for something with an A, not area, not amount. Great. I can see you guys are good with Wheel of Fortune here. P stands for principal. The amount you have at the beginning.
That's too bad.
The Principle. The variables are a little bit different. P is your population. C is our constant of integration. K is your proportionality constant. But it's all kind of the same stuff. All right, so let's finish this bad boy off. So we've got P equals C e to the kt. All right, we got an initial condition. In fact, we've got two initial conditions. Choose wisely. Please choose wisely.
Zero.
Right? If I ever get to
2000.
play with zero, that's the one I'm going to go with. In fact, if you guys have your calculator, you might want to take it out. If t is equal to 0, p is equal to 2,000. So 2,000 equals c e to the k times 0. K times 0 is 0. E to the 0 is 1. 2,000 is equal to c. No calculator needed there. Oh, wait, it's coming. You're going to need it, Jasmine. So P equals 2,000 e to the kt. Look where the 2,000 winds up. Right? It's your initial amount of, not grizzly bears.
Panda
Bears. The initial amount of panda bears. Just like in A equals PE to the RT, your initial amount is what's going over here. Great. I want to figure out how many panda bears at time 13. I can't do that because I don't know what K is. But that's why they were kind and gave you the other initial condition. Right? And this is where you're going to want to have your calculator out. So if t is equal to 7, your panda bear population's 3,000. 3,000 equals 2,000 e to the k times 7. Give you guys a minute to go find k. Or not.
K is 0.0579.
K is, what did you say?
0.0579.
0.0579. Did you divide both sides by 2,000? Did you take the natural log on both sides? Did you divide by 7? Are we all pretty convinced that Giselle wasn't just lying to me? All right. So your population is going to be 2,000 e to the 0.0579 t. But really the final question is, how many panda bears at time 13? Easy.
4,000.
Right, you're just gonna plug in 13, and what are we getting here?
Oh, the actual number?
Yep.
4,246.749.
4,246.749,
749.
but I don't want to think about that part of a panda bear. So 4,247 pandas. All right, nice. All right, tonight, get all the multiple choice problems done. If you get time to do any of the free response questions, that would be a really good choice.
We're not
See you later.
checking them tomorrow.